Hey YouTube, welcome to the next video in this series, Intro to Python. Today we're going to be looking at functions in Python. We're going to look at what they are in general, how to define them in Python, different types of arguments, and how they're incredibly powerful in abstraction and writing clean, clear, and reusable code. Let's get into it. In general, functions is an extremely broad topic, and it is something that does some work on some inputs to produce some outputs. And so, concretely in Python, we're going to learn how to define functions. First, I just want to note that I'm using VS Code for this video as opposed to IDLE, as VS Code is a little bit more full-featured and more of an industry standard. You can absolutely use IDLE in the same way we've been using, but I would recommend you download VS Code, and I'll make a video on that soon. But yeah, let's get into it. So in Python, to define a function, you use the def keyword, and then you name your function. So we're going to call it my function, and we're going to give it parameter 1 and parameter 2. Now, let's recap. So I've said the def keyword that tells Python we're going to define a function. I gave the function name, and I told it the inputs inside brackets. And then you use a colon and hit enter, and then make sure there's an indent. And this will be the function body. So this is the actual work that's done. So if we say our result is going to be a new local variable inside the function that's going to be equal to param1 plus param2. And then the final part of the function is the return statement. And the return statement is the result of the function. And return statements use the return keyword followed by the value or the variable that you want to return. So here we want to return the result. And so with that function defined, we can go ahead and we can actually call the function. So we can call my function on 1 and 2. And if you guys have any predictions about what that will return, feel free to make them now. But we're going to run it. And we actually only see welcome to the video, which is the print statement up here. We don't see anything from our function. So if you predicted that it would output 3, then clearly you understand how the function works, but there's one little aspect where we told Python that this is the function, and we told Python to execute the function, but we didn't actually tell Python to print it to the screen. So in order to get it printed to the screen, we need to tell Python to actually print the output of that function. So we need to say print the result of my function called on 1 and 2. So if we save that, then we get 3 printed to the screen. And so that's how you can make a basic addition function in Python. And this brings up the topic of parameters. So in this function, we used ordered parameters, where Python knew that I was intending the value 1, which I provided first, to go to the first parameter I defined. So 1 maps to parameter 1, and 2 maps to parameter 2. But there's actually other ways of doing this. So you can use keyword parameters. Keyword parameters, the order that you specify them doesn't matter. However, the name of the parameter you actually specify when you call the function. And this can be a lot more readable, and it also allows you to have default values. So for example, let's say we're going to make a function to toast some bread. So we're going to define a function called toast. Toast is going to take in 2 things. It's going to take in a bread type, and it's going to take in let's say, toast level. How dark do you want your toast? You want it very toasted or not too toasted? And the difference here is we're going to specify a default value. So we're going to say bread type is equal to brown for brown bread. And the toast level, we're going to set it on a default value of 4. And so what we can do is then we write our function normally. We say this function is just going to print out some results. It's not actually going to do much, but we're going to say print a formatted string and say and we're going to use the bread type. Your bread type, so brown or white or multigrain or any sort of bread you have, your sourdough bread toast is ready after, and then we're going to use the toast level, we're going to assume toast level is the number of minutes it toasts for. Minutes. And to make this function feel a little bit more real, we're going to actually delay for toast level seconds. So if toast level is 4, we're going to wait 4 seconds to simulate toasting, and then we're going to tell them it's ready. So what we can do is we can call our function to toast some bread. And so take a second and think about what that is going to output. I'll comment out this guy so we don't get that output, but yeah. So make your predictions, and I'm going to run the file. Welcome to the video. We get a delay, and then after 4 seconds, we see your brown toast is ready after 4 minutes. And so we didn't run into the problem last time of it not being printed, because there's actually print statements in the function. And instead of returning something from the function, we straight print to the screen inside the function. So that's another option in some cases. But yeah, we see that we did not pass in any inputs, and so it used the default bread type and the default toast level. If we didn't provide one of the values in our previous function, it would have thrown an error, because it's an ordered argument that needs a value. However, here they're optional. If we actually do want to specify the bread type, so if we want to say bread type is equal to multigrain, we can save the file and we can run the function, and we should get a delay of 4 seconds, and then it should print that your multigrain toast is ready after 4 minutes. And so you can see how functions can be very flexible. You can define keyword arguments that are optional but have sensible defaults, and this is usually a nice way to go. So the next part, we're going to look at how function abstraction is extremely powerful. Basically, all of the programming language that are used in modern day are built on the concept of abstraction. The code that we write abstracts the underlying functions from the user and lets the user just click buttons and read text and use very high-level features in our UIs. And then our languages are actually abstractions of lower-level languages. So, you know, we're very fortunate that we don't have to write this all in assembly code, which is almost machine-level code that tells move these bytes into the CPU, into this register, to do all the operations that we do in modern programming languages. However, we don't have to know that complexity when we program. And so an example here is you can write, say, a complicated function to calculate income tax. And then the programmer who designs the app that it's going to be used in actually doesn't need to know anything about how the function works. It just needs to know that if you pass in these parameters, you'll get these results, and they'll be correct. So if we were to copy in, say, a tax calculation function, so I'm going to paste one in now. You can catch all the code on my GitHub. And this function is, again, the inner workings are really not important. Basically, it takes in a number of your total income, and then it returns the amount of tax that you have to pay. And what it does is it calculates that to be 15% of the first 30,000, 25% of the next 40,000, and 40% of anything after that. But the nice thing is we can actually minimize this function. So in VS Code, I just minimized it, so it's still there, but we just don't need to see it. And we can actually make an application that uses this function without worrying about all the little details. And so what we can do is we can just say print, welcome to the tax calculator. We're going to get their total income, so we're going to say, first we're going to use the float function, which is a built-in function, and that takes in a numeric type or a string type and converts it to a floating point number if that's possible. So we're going to call float on the input function, which gets input from the user, and we're going to ask them what their income is. What is your income? And we're going to store this in a variable called income. So income is equal to the result of the input function, convert it to a float. And then we're going to actually say tax is equal to calculate income tax on their income. And then we're going to print to the user, you owe this much tax in taxes. And so we've actually made a little tax calculation script, and we've abstracted the complex function from our code. And so this function can be changed a lot easier, and we don't have to change anything about how the program flows. So if we run this, oh, we still have the delay from the toasting process. But if you say, what is your income? Let's say someone makes 70,000 per year, then they would owe 14,500 in taxes according to this very simple tax scheme. So that's an example of how functions can be extremely powerful in keeping your application code clean, preventing duplication of code. For example, if you have to calculate income tax in a lot of different places in your app, you certainly don't want to copy and paste all of this code, right? That would be very brittle and not very good practice. So to wrap it up, we've seen how you can define functions in Python using the name, the inputs, the body of the function, and the return the results. We've seen how you can use different parameter types, so you can use ordered parameters, you can use keyword parameters. Since keyword parameters are optional, you can actually pass in no parameters when you call it. And functions are extremely powerful for abstracting complex functions and keeping your code readable and reusable and flexible. So thank you so much for watching. At this point, if you've watched my previous videos and you understand how to use functions, then you can make some genuinely exciting applications in Python. So cheers, and I hope to see you in the next video.